Understanding the fluctuation of space and time made super simple. Most of us grow up thinking that space and time are like a smooth, unchanging stage where everything in the universe happens. For example, when we walk from one place to another, we don't feel space changing under our feet. And time? It always seems to tick forward at a steady pace. But what if I told you that, deep down, at the tiniest level of reality, space and time are not calm at all, they're actually constantly shaking, bubbling, and fluctuating? What does fluctuation mean here? In simple words, a fluctuation is a tiny, temporary change or movement, like how your voice goes up and down slightly when you speak, or how a flame flickers. So, when we say space and time fluctuate, we mean that they are not perfectly steady. At the smallest scales of nature, they behave like they're vibrating or twitching randomly, even though we can't see or feel it in our daily lives. Why does this happen? This strange behavior comes from quantum mechanics, the branch of physics that deals with the tiniest building blocks of nature, like atoms and particles. According to a key idea in quantum physics, nothing can be completely still or exact. There's always a bit of uncertainty. This rule applies not just to particles like electrons, but also to space and time themselves. When we zoom in extremely close for smaller than atoms, down to what's called the Planck scale, we find that space and time are no longer smooth. They behave more like a restless ocean, with constant mini waves and ripples. This is sometimes called quantum foam because it looks like the frothy bubbles on the surface of a boiling liquid. An easy example to use an example to make this crystal clear. Imagine you're looking at a calm lake from far away. It looks perfectly still and flat. But if you crouch down and look closely at the surface, you'll see tiny ripples, bugs moving, and little waves. That's how space and time look at the smallest level, not still at all, but full of tiny ripples or movements. Or take another example. You're walking on a football field. To you, the ground feels flat and smooth. But if an ant were walking there, it would feel every little bump, crack, or blade of grass. In the same way, humans experience space and time as smooth, but tiny particles living at the quantum scale feel the fluctuations. Do these fluctuations matter? Yes. Scientists believe these tiny fluctuations can have huge effects over time. For example, they may have played a role in how the Big Bang happened, which created the universe. They affect how black holes behave, especially at their edges. They might help explain mysterious things like dark energy or the expansion of the universe. In theories like quantum gravity or string theory, these fluctuations are actually part of how the universe is built at its core.